Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of What to Look For in the Night Sky. We're talking about the week of May 12th this time around. Another big week. They're all big weeks. Lots of good stuff going on. We've been watching Mars and Jupiter. And so let's think about Jupiter. Jupiter is about 1 degree from the Crab Nebula. We looked at it relative to the Crab Nebula in Taurus last week, and said it's moving toward there. And so on the 15th, it gets within about 1 degree of the Crab Nebula, which is pretty close. But what's happening as we get to the 15th of May is Taurus is fading into the glow of sunset. So this gets to be harder and harder to see. Jupiter you'll see. But something like the Crab Nebula gets to be harder and harder to see because we've got these constellations of fall and winter disappearing in the west. Likewise, Mars was by the Beehive cluster last week, and it's been pulling away. Been pulling away for Castor and Pollux and Gemini. Hope you've had a chance to track it. It's been fun watching it move across the sky. By the 3rd week of June, it's going to be near Regulus, right on top of Regulus, the star in the base of the sickle of Leo. And so it's going to be all the way over there in Leo. By that time, this will be getting to be a little bit harder to see in the west. So we see the stars just moving around and getting closer to setting like this. I think you'll still be able to see this, but this is going to be harder by that point, and we'll be looking into the glow of the western horizon there, which makes me want to think about the fact, you've heard me talk about this before. We have constellations that we associate with certain times of the year, and it's always surprising to see them. Leo, got an early spring constellation. We see it now in June. We'll still be able to see it, even though we're working our way into summer. Should be able to see it pretty well still. What I've been noticing this week is the great square of Pegasus rising in the morning sky just before sunrise. So you get out a half an hour before sunrise, an hour and a half before sunrise, and you see this great square of Pegasus climbing over the eastern horizon. This is a true marker of the fall sky. We think about the stars associated with a certain sky because we see them in the evening at that time of the year. But now if you get up first thing in the morning, you're seeing the great square of Pegasus with Andromeda. And the Andromeda galaxy is now there in the morning sky. And we can see it here right in the middle of spring, even though this is an iconic fall constellation and fall part of the sky. So all of this has me thinking about sidereal versus solar days. And I'm sure I've talked to you about this before, is to say, okay, there's the sun, and here's the earth. We can build a monument, an arrow that points directly at the sun. But we're rotating like this. And so noon, that arrow is going to point directly at the sun at noon. It's nighttime over here. A day later, we will have moved in our orbit over here. I've exaggerated that a little bit so we can see it. But we will have moved this direction, and we will have rotated around one rotation. And one rotation around, you notice that arrow is not pointed at the sun anymore. We have to over-rotate to get that arrow pointed back at the sun, and we have to over-rotate by about 1 degree because we moved about 1 degree in our orbit. 365 days to go 360 degrees in the orbit. It's a little bit elliptical, it's speeding up and slowing down. There's some things going on, but it's about 1 degree that we move, and so we have to over-rotate by about 1 degree. Now, if you do the math and say we rotate about 360 degrees in about 24 hours, you realize it takes 4 minutes to rotate that extra degree. And so we have our clocks based on the sun, and say our 24-hour clock, the rotational period of the Earth is actually 23 hours and 56 minutes. And so it takes that extra 4 minutes. And that means the stars, which are way the heck out there, the stars don't care that we've moved a little bit. That would be parallax that we measure in the stars. And it took us forever to find parallax, to actually even be able to detect it. So the stars move little and all as we move across here, their apparent position. And so the stars end up rising, getting back to the same spot in the sky 4 minutes earlier each day. And so we have nighttime that's out here. By the time we get 6 months later, we're over here, and nighttime is way up there. And so we see that season. Those are the stars that we associate with night. These are the stars that we associate with night. But because of our rotation, because we're doing this moving, we actually have a fair amount. New stars are rising into the night sky all the time, and we can see a fairly large fraction of the sky. And that's what we see going on here as we think about Leo and as we think about the great square of Pegasus and being able to see both of these in the same sky right now. And Taurus, for that matter, that we're looking at here this week. Also this week, it's a bad moon week, tough moon week. On the 13th into the 14th, the moon's almost full, and it's just within 1.5 degrees of the bright star in Scorpius Antares. So watch for that. By the 18th in the morning, this moon is not rising until after about 1 o'clock in the morning, and it's very near Pluto. This is an academic thing. We've talked about this before. You're not going to be able to see Pluto next to a moon that's that bright. But it's less than 3/4 full now, and it's sitting near Pluto. So by the time you get to the 16th or so, the moon's rising after midnight. That gives you some of the evening sky. Get out at 9:30 and take a look, depending on your local time when it gets dark, and take a look at some things in the evening sky. And we're going to go back to looking at galaxies in the Virgo supercluster. We've been talking about this spring because that's what spring is for. Spring is for looking at galaxies as we look at this region of the sky. So I'm going to try to clean this up a little bit. But we've got the triangle tail of Leo that's right here. And this is Denebola, and Regulus is here. That's where Jupiter's headed toward Regulus in about 5 weeks or so. We'll see Jupiter 4 weeks, probably by the time you're watching this. You'll see Jupiter near Regulus. But out here on the triangle tail of Leo, Denebola translates as tail of the lion. If you move up this direction, so you extend on out this way, so you move up this direction, you come to 95 Leonis, a 5.5 magnitude star. My guess is wherever you are, you probably can't see that. Unless you've got binoculars or a telescope. Then you come to a 6.4 magnitude star. I'm sure you can't see that. That is the 3 Coma Berenices. And then you come to the brightest star along this path that maybe you can see if you've got good dark skies, a 4.7 magnitude 11 Coma Berenices. And so you've got this 4. So that might be the first star you see when you travel. You pass a 5.1 magnitude this star over here, 6 Coma Berenices, and we'll come back to that in a future one of these. But you pass 6 Coma there that you might be able to see along the way. So if you've got a good dark sky, you might see Denebola. You will see Denebola. It's a big bright star. You might see 5.1 magnitude 6 Coma, or you might see 4.7 magnitude 11 Coma over there. So we're aiming for this star right now. And we get to 11. It's a nice double star. It's a nice binary star. Separated by almost 9 arc seconds, the two components, which means you don't have any trouble splitting them. You can see those two stars, but the companion star almost, I think it's 12.8 magnitude. It's almost down to 13th magnitude. That is not easy to see. If you're taking a photograph with the CCD camera, you'll see this, and you'll get a nice binary star in there. But you're going to need a pretty big telescope. I'm going to say you might be able to do it with an 8-inch telescope, but a 10-inch telescope or a 12-inch telescope. Let's say 10 and maybe 12 would be better to try to split this binary star. So you got a good-sized telescope and you want a fun task, a fun thing to try. Go out and see if you can split 11 Coma Berenices after you get there from moving off Denebola. Now, I see I've been leaning against the board, making all kinds of mess. What we're going to use, the reason we get to this star, is we're going to use this star. Just 1.6 degrees to the north of this star is M85, a nice galaxy in the Virgo supercluster of galaxies. We've looked at other galaxies in previous weeks. M85, we're going to use 11 to get there because we just go just over 1 degree to the north. So in a low-powered eyepiece, for a lot of you, depends on your telescope, but for me, in my Schmidt-Cassegrain telescopes that I use all the time around here, what I'm talking about is a 40 millimeter eyepiece. The larger the focal length of the eyepiece, the lower the magnification. And we're talking about something on the order of 40 millimeters would do this job. We're going to see that galaxy, a pretty bright galaxy. So it's a pretty bright elliptical galaxy. We've talked before, elliptical galaxies are often the biggest, brightest galaxies in a cluster of galaxies like this. So this is a big, bright elliptical galaxy just about 1 degree north of 11 Coma. So if I get 11 Coma in my field of view, even maybe with a medium power eyepiece, a 26 millimeter eyepiece, that would be for me, I'm going to see M85. If I go the other direction, drop to the south and to the east, I'm going to find M100, and M100 is the largest spiral galaxy in this region, also a big bright galaxy. So these are big bright galaxies, and we should be able to see these. Now, we might have a hard time getting 11 and M100 in the same field of view. You might have to move your telescope a little bit to find that, but you should come across the fuzzy patch that is M100. M100 is a nice big spiral galaxy, and it's probably pretty close in size and structure and morphology, we would say, to the Andromeda galaxy, our nearest neighbor full-size galaxy that we saw here. That's the biggest galaxy in the local group. And so this is the biggest galaxy in this region of the sky, biggest spiral galaxy, excuse me, in this region of the sky. And so you can find M100 down there. So these are things to look for. If you want to do this work later in the week, by the time we get to the 16th or 17th, and you've got the moon rising after midnight, then you can get out in the evening sky. For us lately, we've had beautiful warm evening skies, so you can get out evenings. And so you can get out in a beautiful warm spring evening if you're watching from mid-northern latitudes like I am, and you can try to find these galaxies. So try to see, you got a good-sized telescope, try to see if you can split 11 Coma Berenices. If you have a slightly smaller telescope, you'll probably be able to see M85 and M100. You don't need as big a telescope to do that. Enjoy just identifying these stars. See if you can find, with your binoculars, can you find 95 Leonis? Can you find 3 Comae and 6 Comae over here, and then get up to 11 Comae? That's all great. Think about why we see different stars at different times, why the stars rise a little bit earlier each night. You got the moon near Antares one night, and we've got the planets here for a little while longer. And think about, again, what parts of the sky we can see when. So that's our week ahead. It's a great week, the week of May 12th. As always, everybody, thanks for watching, and we hope you have a fantastic week ahead.